So this video is the solution to the 2023 Living Set Higher Maths Paper 1, and this is question 1. So we're asked to find the two values of m for which the absolute value 5 plus 3m is equal to 11. So 5 plus 3m is equal to 11. This will give me 5 plus that gives me 3m. That gives me 3m is equal to 11 minus 5. 3m is equals to, or that I should say, 3m is equals to 6, and then m is equals to 6 over 3, not 4 there, 3, which gives me 2. So our first m is 2. Remember, we are asked to find two values, so we need to look for the second one. So the second one will be the absolute value of a negative value is also a positive value. What do I mean by that? So if we have here the absolute, this is how we denote absolute value. So if I say absolute value of 5, this is 5, but the absolute value of negative 5 is also 5. So the negative value there, so negative minus 5, the actual value of that number. So the negative sign is just to symbolize which side of the number line it lies, but the actual value there, if you have to make a displacement, it's still going to be displacement 5 steps on the left towards the negative axis, x-axis, and if it is positive, we're moving towards the right. So it's still, the absolute distance is still the same, negative 5 and positive 5. So the absolute value is still the same. So the absolute value of negative 5 is still 5. So if we come here and then we say here, so in negative of 5, the absolute value of 5 plus 3 is still 5 plus 3. All right, is equals to 11. And then we go, now we expand now. So negative 5, negative 3m, we're expanding with the negative sign there. It's gonna give us 11. So negative 3m therefore is equals to 11. When negative 5 crosses over the equal sign, it becomes, the sign of it, the operator changes, it becomes positive. So it becomes 11 plus 5. And then, so if we divide now by negative 3, so we're going to have m is equals to 11 plus 5 is 16 over negative 3. So it's going to give us negative 3. So this is our second value now. So m, so the two values are m is equals to 2 and m is equals to negative 16 over 3. So this next one is question 1b, and you can see here for the real numbers h, j, and k, express k in terms of h and j. So this one is also an easy one. So this is just common mathematics. So I'll just cancel everything and just take over again. A fraction is equal to another fraction. The simple way to begin is to cross multiply. So we cross multiply. So we cross multiply. When we cross multiply, we're going to have j k times 1, j plus k. So this times this, and then this times this. That's what we mean by cross multiplication. So we are cross multiplying. So j times 1 is jk is equals to h times k is hk. So then, so we can see here now that so we can say j is equals to hk minus k, okay, which we can factorize. This is the same as k into h minus 1, right? When we factorize our k here, so then we can now have j over k, j over h minus 1 is equals to k, because we can then divide here by h minus 1, and then we divide this other side by h minus 1 as well to have k. So j over h minus 1 is equal to k. So this is our last value here. This is what we're asked to do. So that one was as simple as well. Okay, we move over now to 1c. We've done 1a, b, and now this 1c. So x squared plus negative p squared plus 1 is a factor of x cubed negative 2x negative 3r, where p and r are non numbers, rational numbers, and p is less than 0. Okay, so so if we see here, this is indicating that this two factors of the equation already. So if this equation is a factor of this, it was the other equation there, of this equation, and this one already has x squared, which means this one contains two factors already. So the remainder here should only be one factor. If we divide this by this, we're going to have the answer should be the remainder of the factors of this equation. This equation is meaning that this is a polynomial, which means, or trigonometry, which means there are three values of x. We know that by the index here, when x cubed means there are three values of x, and here x squared means there are two values of x here. So this factor already has two factors of this equation. So if we divide this by this, the answer will give us just x to the first power. Okay, just x to the power 1, because that will be the last factor of which is remaining. So but then we can just equate it. So we are saying, so if this is already two factors, because to get the factors of this is x plus something, let's say x plus k. K is an arbitrary number, letter. We can just use any letter to represent that. This is like x plus k into x into x minus k, or plus k again, whatever, 3 times. That's how we got x cubed, telling us there are three values of x there. That's something like that. So but if this part already has two of this, so we should have only this one which we are looking for, which we don't know. So that's what we're expressing here. That's what we are expressing here. So this is the last part. Let's just say this one was supposed to be in the positive there. Sorry. Supposed to be a positive there. Okay, so this is two parts. So these are the three factors of this equation here. 2 in this equation and 1 in this equation. All right, so these are the two factors. We're just expressing what is said there. All right, now if we do that, we can now compare the coefficients. Let's say we expand this one first. So when we expand this one, we're going to have x cubed negative p x squared plus x minus kx squared. We are simply expanding, okay, plus kpx negative k. And then we can now equate the coefficient. If you look at it here, this we have 3 x cubed here, plus x cubed over the equal sign. We have another plus x cubed. So these two x cubed is going to cancel each other, because x cubed take away x cubed. If we bring it the other side, it's going to be 0. X cubed take away x cubed is 0. Okay, so this one is gone. This one is gone. This one is gone. So what we're left with now is, on this side we're having negative 2x negative 3r, and on the right hand side we're having, or the right hand side of the equation of the equal sign, we're having px squared plus x negative x squared plus kpx negative k. So we now check the coefficients of each term. Okay, to do that we need to first group our terms, bring like terms together so they look identical, which would then facilitate our next step, our next process. So to do that, we group together. So on this left hand side, remember 3d x cubed is gone. So we have the coefficient of x squared on this left hand side is 0, because there's no x squared. The reason we putting x squared here is because the right hand side has x squared. It has term that has x squared. So we are trying to equate. So what is the equivalent of x squared on the left hand side? It's 0. So if there's x squared there, the coefficient is 0 because 0 times x squared is 0. So we just represent it like that so that it looks identical, okay, just for identification, or identical, yeah. So so x squared, 0x squared, 0x squared, as I said, because there's no x squared here. Then negative 2x, because an ordinary equation would be a polynomial. The third index is gone, so the next one will be s squared plus something else plus c. That's how equation is always expressed, yeah. X squared plus something x plus c. So the power of x second time, the power of x one time, and then a constant, okay. So x squared, 0x squared, negative 2x, negative 3 minus negative 3x, 3r. So the 3r here is like the c, all right, and then 0x squared, then this 2 here is like the b, if you remember the equation of a quadratic equation, all right, or of a line or something like that. And then on the left hand side we bring like terms together, so we bring all the terms having x squared. So we have kx squared and px squared, so we bring them together. When we bring these two together, we see now that we can factor out x squared, and when we factor out x squared, we're going to be left with negative p, negative k in this bracket here. Then this is our plus, and then we bring together also the x, the power x, the x with power 1. So the terms having x in them, because we finished with the term having x squared. Remember, x cubed cancel x cubed, so x cubed doesn't exist anymore. So we're having x squared and x, and then c, which is k here in this case. So we bring we finish with x squared, we have x. So when we bring x plus x, negative kpx, if we bring them together, because they have the like terms, so they form one term. And then we can factor out now x, and when we factor out x, we're going to have 1 negative kp, which you have there in the bracket here, and then our negative k, which is the one remaining. So we can now compare the coefficients now, as you see in the black ink here, equate the coefficient on both sides of the equation. All right, so that's the next step we need to do now. So as I said, x cubed is gone. Then we have the coefficient of x squared is 0 on the left hand side. Okay, so the equation on the left hand side of x squared is 0. That's why you see 0 here is equals to the coefficient of x squared on the right hand side is negative. Remember, we're not saying x, what's the coefficient of x, because it's like negative p negative k squared. It's like negative p negative k squared. So the coefficient here of x here is this, just so we can have 3x squared. Then 3 is the coefficient of x squared. That's what I mean. All right. So we come back here, and then we say so okay, so the coefficient of x squared on the left hand side is 0. The coefficient of x squared on the right hand side is negative p negative k, which is the same as k. If negative p negative k is equals to 0, then we're going to have k is equals to negative p, of course, yes, because if p goes over here, it become positive p, then we cancel out, we multiply by negative. So in order to cancel, what I mean is, so we have there negative p negative k is equals to 0, and we're looking for k, so we have negative k is equals to p, because p crosses over and the sign changes. Then we multiply, we are looking for k, not negative k, so we multiply both sides by negative, so we have k is equals to negative p. So that's how I got negative p there. Okay, so we're here, we have this one now, negative k is equal to negative p, and then the coefficient of x, remember we finished with the coefficient of x squared. The coefficient of x on the equations are on the right hand side. The coefficient of x is negative 2. You can see it here. So the x squared is 0, and then the coefficient of x is 2 here. Okay, so it's 2 there. So 2 is equal to the coefficient of x on the right hand side is 1 negative kp. So this is it here, 1 negative kp. That's the coefficient of x there. Okay, so 1, remember, is the same as 1 minus kp x It doesn't matter because I put x at the front. It's still the same like this. Yeah. So 1 negative kp, that's the coefficient of x there. And then 1 negative kp, which is the same as that gives us kp is equals to -2. When 1 goes over there, it becomes -3 and -1. So we have -3. So we have negative kp is equals to -2 -1. So kp is equals to negative. We're multiplying by negative now because to get rid of the negative sign on the left hand side is equal to negative into -2 -3 -1, which is going to give us -3. So kp is equal to -3 gives us 3. That's how I got 3 there. Okay, so we're here. So, but remember we said k we had k here. We said k is equals to -p. Excuse me. So we can now substitute instead, in place of k, we insert -p. So we are here. We said kp is equals to 3. That's why we have -p squared, which means negative k is equal to -p. So this k, then p times p. So -p times p is going to give me -p squared. So that's how I got -p squared here is equals to 3, because we said kp is equals to 3. So -p times p, because k is -p. So -p times p is equals to 3. -p squared. So -p times p is -p squared times p is equals to p. So that gives me p is equals to, okay, so let's go like this. -p squared is equals to 3. To get p, so let's say we multiply both sides. Let's get rid of the negative sign first. So we say p squared is equals to 3, -3. P squared is equals to -3. -3. That gives me p is equals to plus minus, because it's square root, we're looking for square root, so p has to have 2 values, a negative value and a positive value. All right, so a square root is always 2 values, yeah, the negative and the positive, because -2 times -2 is 4. 2 times 2 is 4. All right, always 2 values, negative and positive. All right, so p squared is equal to plus minus square root of -3. All right, okay, no, so it's -3, square root of -3. So that will give us so 2 values of p. The first value is p is equals to plus negative square root of 3. That's going to give us, plus negative is negative, so that's going to give us negative. So we are going with the plus side first, so it becomes plus minus square root of 3. It's going to give us minus square root of 3, and then this p, that's p1. P2, the second value of p is we'll go with the negative route this time, so negative square root of 3 is going to be positive square root of 3. Okay, so these are the 2 values of p, but which of these should we take? Should we take -3 as negative square root of 3, or should we take positive square root of 3? So to know which one to take, we have to go back to our equation, to the question that was asked. The mission statement, p is less than 0, so we should look for the p which is less than 0. So in the first p1 is negative square root of 3, which is less than 0. P2 is positive square root of 3, which is greater than 0. So this one, we discard this one, and then we take this one. So p is equals to negative square root of 3. So that's why this p is brought here. So p is equals to negative square root of 3. Okay, so we have our p up there. No, we have our p here. This is our p. Now we were asked to look for 2 values there, r and p. Well, so we have r, we have p now. P is the negative square root of 3. Now but we know that 3r is equal to p. So from here, we know that 3r is equal to p. What is it? So because if you look here, we are going to the coefficient. Now remember, on the left hand side, the constant c is represented by 3r from that equation, 0x squared negative minus 2x minus 3. So it's like ax squared minus bx, which b is 2 here in this case. If you remember the equation of a quadratic equation or of a quadratic line of a curve, then negative 3r will represent c, because there's no x in this term, so that's why it is represented as c. On the right hand side as well, we did the same thing, and our in this case, because this term has x squared, this term has x, this term doesn't have x, so this is the equivalent of c on the right hand side. So the equivalent of c on the left hand side, negative 3r, must be equal to the equivalent of c on the right hand side, which is negative k. So that's why we have here 3r is equal to negative k. So k is equal to negative p. This is here, so which is what we evaluated here. So k is equal to negative p. That's what we got here. So 3r is equal to p. So if we evaluate that here, k is equal to negative p. So if 3r is equal to negative k, so that means 3r is equal to negative, this is a negative here, then bracket negative k is negative p. So negative, so negative p is p. Okay, so 3r is equal to p. And then if 3r is equal to p, and then we know that p is equal to negative square root of 3, as we found here. P is equal to negative square root of 3. So as you see, 3r is equal to p, 3r is equal to negative square root of 3, then r must be equal to negative square root of 3 all over 3. Okay, as you see here, this is our final solution. So p is equals to negative square root of 3. That's what we found. Then r must be equals to negative square root of 3 all over 3.